In this video, we are going to discuss about feature importance. So to understand about the feature importance, you need to understand and know about the dependent and independent variables. So I have been telling you from the earlier of this section that this attribute here is cancelled. So this is a column. We can call this column as attribute. So this is what we are going to predict by using machine learning algorithm in the upcoming section obviously, but for now this is what our machine learning model will be predicting, and our machine learning model will take all the other things except this as an input and it will give this as output. So that means whatever the machine learning model will give us as output will be our dependent variable, and all the remaining that has been highlighted with the yellow thing over here, all these things, even this is also our independent variable. So all of these will be our independent variable, and these independent variables will be used to predict this dependent variable. Now for that, and in order to understand the feature importance, let us just distinguish this independent and dependent variable. So I'll just distinguish it right here. So I can say that it is to separate dependent and independent variables. So first I will give y, small y, and if you remember, we have this data frame, and from this data frame, if I want to just get is cancelled, and if I print the y, then you will see this is what our dependent variable looks like. So this is what our machine learning model will give us as output. So this is dependent variable. Now similarly, I will just name it x, and I will name it x, and I will say it is a independent variable. So for the independent variable, I'll just call the drop function on this data frame, and I'm going to drop is cancelled, and I'm going to just have all the other attributes except is cancelled attributes, and the drop should be along the y-axis. Now this is dependent and this is independent. Now machine learning model will take this x and it will give us y. That is what machine learning model will do. Now over here, if I print both of them, first of all, let's say I want the head of the x and the head of the y. So first of all, let us see only the head of the y, then you will see it is the dependent variable. And now time to get the head of the x, and you can see this is what we have here. These are all the attributes our machine learning method or machine learning model will take, and it will give us the y. It will take x, it will do some mathematical computation, and it will give us y. So this is what the separation of the independent and dependent variable means. Now from this x, we are going to predict y, but everything that is inside this x data frame, let's say I want everything to check from this, you can see we have everything that is related to the independent variable right here, lead time, arrival date, everything, and the data looks something like this. So in this data, maybe we don't want each and everything. We want only certain part of this data. We want only the important features. So that is the feature importance. From this, all the values of x, all the columns of x, I won't be using all of them. Rather, I will be filtering out the important feature, and if the features that are not important to predict y, then I will remove them. I will not use them, because if the feature is not important, why bother to use them? Why we need to waste our resources, maybe Even using those useless feature might also degrade our accuracy. So that is the reason we need to filter out those features, those attributes that are not relevant to predict the values of y. And that is what feature important means. Now, using the feature importance, I'm going to predict which of these attributes are important among all of these and which are not. And I'm going to use some model, and the model that I'm going to use is from scikit-learn. I'm going to use the linear model. The linear model, I'm going to import it, and I'm going to import the lasso regression here. So the lasso. So next is I'm going to import the next method, which is commonly used for feature selection, and in fact this model has the attribute feature selection. And from this I'm going to use select from model. This is the two library that we normally use in the case of feature selection. And now this is not a feature model, this should be feature selection. So if I run it now, everything is imported. Now we can use this to perform feature importance tasks or feature selection tasks. So for that, first of all, I'm going to create a model using this library that we have just imported. So select from model, which is right this method. I'm going to use it, and I'm going to use lasso to create a model. And here we can give multiple arguments, but the most used argument is alpha argument, and the next one is random state. So here the random state is for the reproducibility, so that our answer might not be random every time we run this model. And the next value is alpha here. Alpha is a penalty here. So penalty means the penalty that we want to give to the model if it incorrectly classifies some features. So if you select the higher value for this alpha, then you will get the less feature. So among all these feature, less feature will be selected. But if you have the proper value of alpha, then the proper number of attributes will be selected. So it's up to you. It is an hit and trial method. You can also use as a hyperparameter. You can hit and trial this value and check which values of the alpha best suits on your situation. But for now, I'm going to stick with this one. And now, next thing is, let's say I want to just have a feature select model, and I'll just store it here. I'll run it. Now our selection procedure is created with a lasso model, and the alpha here is a penalty. If you have the higher values of alpha, you will end up getting the less number of attributes. If you have higher values of alpha, then less. If you have lower values of alpha, let's say you give some values that is really less than 1, that is really less than 1, then basically you will end up having many or almost all the attributes. We don't want that. Rather, we will stick with some appropriate values, and in our case this might work. And if it doesn't, then we can also always change this value and check which value we would get the most appropriate, that is the columns. So we want the subset of this entire column. We don't want each and everything. We want the subset, and the subset should be best representable. It should be the best subset. So after the model is created, next thing what I want to do is I want the support from each of this model. Maybe I can also fit using this model, features selection model, and I'm going to call this fit function, and I'm going to pass x and the y. So x here is the independent variable and y is a dependent variable. So using this model, we are going to just fit a model known as lasso regression, and it is going to check which of these are mostly correlated with the dependent variable. And in this way, we need to fit the model. Let us run it. Now the estimator has been executed right here. See the estimator. Now next thing is we need to get the support out of this model. So features select model and get I'll say dot get support. Let us run it and check what does it means. So see here, some of these values are false. So if you check these many attributes and these many values, then that means the support from each of these values to predict the y will be true if there is high correlation between the independent and dependent variable. So that was the reason over here. Now we can use this get support and extract only those values which has the true to it. If there is a true, I'm going to select it. If there is a false, I'm going to disregard it. So for first, this is a true. So you can see the column says true. So that means lead time is an important feature. The second is true. So arrival date, week, number is also important feature. The third one is false. So for the third one, arrival date, day of a month, this attribute is not important. So that is our conclusion from this lasso regression model. Now let us write a code that will just select only those attributes which has true to it, otherwise we will reject for them. So I'll just say x columns. If you run it, then you can see it contains all the columns that we have, all the columns. Now next thing what I want is I want to get the selected feature. So from the columns, because the columns contains each and everything, I don't want each and everything, I want only those which have the true value to it. So from the columns I need to refine it. So feature, this same method, feature select model dot get support. So feature select model dot get support, and if it is a true, then we select that model, otherwise we reject that model. And this should be wrapped inside a parenthesis. I'll put one extra parenthesis to it. Now if I run it, if I print the selected feature now, right here, this is selected feature. If I run it, then you can see now, initially it was all of these attributes, now it has been, that is reduced to this much only. Now we will be using this in order to predict y. Now our final x will be this value. So this way we can just stem our data. So instead of using so many features, we can only reduce and only select those features that are important to us. So I can also give you some stat right here by printing. Let's say I want to print, initially we have total features. I'll say total number of features, where, okay, I'll just print it by F formatting, and the total features initially were, that is x dot shape, and I'm going to get 1. Will it work? Yes. So initially we had 28 features. Now after we did this model, after we use this concept of a feature selection or a feature engineering, then I'll see the features that has been reduced. So let us count selected features now. Now the selected features will be the length of selected feature. If I run it, then now after performing this concept of feature importance, we reduce the initial size of a feature to 16. Now if you just subtract this value from 28 to 16, what you will get is, you will get those attributes which are not important for us. So only the important feature is this 16. These 16 features are important to predict the dependent variable. Now we will refine our data, the independent variable, using these selected features. So for that, I'm going to get our initial x. If you see, this was our initial x. Maybe I can check the initial columns of the x. It was all these columns, but now I want to override this with only the columns that has been selected. So for that, I'll say x and x selected features with these features, with this selected feature. It is only feature, not features, selected feature. Now if I run it, now after we do it, I can go down and again call the columns. Then we have finally our best features that can be used to predict the dependent variables. So finally our data frame is ready, and our data frame contains x and y. So x, if I call the head to it, then this contains this many information which can be used to predict y. And what is y? Y is our dependent variable. This is our y and this is our x. We are going to use this x to predict y, and we are going to do that in the next video, where we will build the machine learning model and we will test our model.